After finishing building the steering assembly of the future go-kart, I realized that there were a lot of improvements that could be done to the Miranda blocks. And being this early at the production stage, meaning that I've only printed a few, I think this is a great moment to make the blocks as good as they can be. Or maybe it's just me overcomplicating everything again. Who knows? Most of the time, when I'm designing a new machine, there are lots of variables that affect and constrict the design. The rotor diameter, maximum available rail length, the extrusion dimension, the rigidity of the chosen material. But when designing these blocks, there was only one thing that was going to restrict the rest of the design. The bearings. I was looking for a bearing that was reasonably affordable, thin in both dimensions, and with a large inner diameter, so we could fit through it shafts, axles, and most importantly, 3D printed screws that could withstand the forces of whatever we want to build with it. So anything. In this version, I went for these bearings that have a 45mm inner diameter, which gave me plenty of room for large screws, and also big extrusions like this one to make shafts and axles and a lot. And the outer diameter is just 58mm, which makes it only 6.5mm thick, which is pretty good, and to make it even better, it is only 7mm tall. And with that bearing chosen and having done all these different tests, I finally settled on this final dimension and pitch. And with these screws, it was all fine. But then I realized that the blocks weren't registering against each other. So I had to position them very carefully when fastening the screws. And then is when I made these spacers. And this made the blocks register against each other, and then you could just put the screws in there, and that's it. But during the build I realized, and I cannot believe that I'm going to say this, that those were going to be a lot of spacers. And there's where the first improvement came to mind. What if I made the screws as wide as the holes? This way there is no room for movement, and this way I can get rid of having to add at least 2 of these whenever I join 2 blocks. But with these half-pitch holes on the sides, whenever I put one of these in a top hole, part of the hole of the 2 sides gets covered. So I cannot use one of these in here and then in here or in here. Because remember that I told you that the inner diameter of the bearings is 45mm and the pitch between the top and side holes is 42mm, so there is always going to be 3mm of interference between the top and side holes. And that was going to limit a lot the building options, so there are a few solutions. For example, use a larger pitch, but I don't want to throw away everything that I've already printed, and I also really like this size, so I decided to keep the pitch and use a smaller inner diameter bearing. So instead of the 45mm inner diameter, I'm going to have 40mm inner diameter. It's smaller and riskier, but this will have to do, right? And with that decided, I started working on a new improvement based on another issue that I found during the build. What happens when you have 2 blocks that have already been joined side by side, and you have to join another block from the other side in the same point? Of course you could use a larger screw, but what happens, for example, when you don't have access to the other side, or you don't have a screw that is long enough, or you don't want to print like 1/2 meter screws? So I came up with this. This is a screw that has a thread through it, so you can insert it in the hole and exposes a thread to the sides, so you can just add a screw on one side and a screw on the other side, and that way you can join blocks through the sides of one central block. Pretty convenient. If it wasn't just because with the offset of the side holes, you will not be able to see the threads through here. And to be honest, at this point, I cannot remember why I added the offset holes on the sides. I have no idea. So I went back to Fusion 360 and removed the offset of the holes, and now you can just add this in here, and there you have the thread. And now you can fasten the screws on the sides. Perfect. So I printed a few parts. Just to see if everything was working correctly, this design is compatible with the previous one, at least pitch-wise, And although I had to buy new bearings and so on, I think this design works great. But there is a circle that is just about to close. It took a few days for me. I will not lie to you. If you want more time to try and guess it by yourself, this is a great moment to pause the video. And again, this took a few days for me. If the holes aren't offset anymore, and I put this in here, the pitch between the holes in all four sides is 84 millimeters. So there will be no interference between anything that I put in this hole and this hole, as long as it is of a diameter smaller than 84 millimeters. So the previous bearings that were 45 millimeters now are just fine. There is no need for new bearings. So there is no need for new holes. So there is no need for new screws or new anything. The only thing that I needed to change is remove the offset of 42 millimeters between the top and side holes that, again, I cannot remember why I did in the first place. So yes, these blocks with no offset are good, but I will get rid of the rest of the design changes related to the bearings. I will keep the thick screws and everything, and I will keep this design. I like it way more than this one, right? This design is just fine. I just need to remove the offset on the sides. Oh, and I will keep this teardrop design here because bridging is way better now. With all this design back and forth, this is a great moment for a quick ad from today's video sponsor, Xometry. Xometry's quoting engine is quick and simple to use. Anyone with a CAD file can upload their design to Xometry's instant quoting engine and within seconds get instant pricing, production lead times, and DFM feedback. With over a dozen manufacturing processes to work with, Xometry offers an exceptional range of options, from different types of 3D printing and CNC machining to sheet cutting, injection molding, die casting, and more. Xometry also offers thousands of materials and finishing options, and you can select from a number of economic, domestic, and global shipping options to impact lead times. Thanks to Xometry's immense network of over 5,000 global manufacturing partners, ordering with Xometry is more affordable than most options. Xometry offers a number of smart and easy financing options, so you can get the parts you need now and pay later. No matter how big or small your custom manufacturing project may be, you can start your manufacturing project with Xometry. Visit xometry.com/Miranda to get your design quoted, produced, and in your hands in no time. And now let's see where this is going. I'm beginning to think that testing new designs in this huge size is a bit insane. Just a little bit. So in line with my question on my last video about a scaled down version of this, I did this. I don't think that this is less insane, that this is more or less a scaled down version of the Miranda blocks. And one thing is for sure, it's going to take a lot less time to try and do tests with this than with these huge parts, which are also quite heavy. So let's try and replicate this with that. Another of the improvements is that instead of having a dedicated rack part, I've divided this part between the rack itself and a standard 4-height block. And now I can add racks everywhere. as you keep asking in the comments, all the plastic parts in the 3D printed small scale version and large scale versions of the Go Kart are printed with Polymaker's Polylite PLA in red, and the tires are printed with Polymaker's Polyflex TPU. Remember that Polymaker sponsors my madness through filament for all these builds, so go and check the link in the description and send them some love. On the left side wheels, I'm using left side threads that fasten the other way around so they don't get loose while the wheel is spinning. And I made this notching here for the left side ones so I can distinguish them from the right side ones. On this small version I will try to use a plastic rear axle, but in the real one I will be using an aluminum one because it not only has to withstand my weight and the weight of the go-kart, but also the power of the motors and the brakes. Because Matt and I have already been talking about the competition.
Somewhere we should probably have a drag race, and then we should have an agility race.
Yes. You know? And have already agreed to some limitations.
Because if I put front brakes in mine, it would be an advantage, I think, at this point.
Yep, it would stop.
So for now, only rear power and rear braking. By the way, if you haven't watched the first video, this is for a competition against Matt Denton and his own Lego Inspired 3D printed Go Kart. So while we are at it, go and check Matt's channel and his Go Kart. How cool is this? I've already printed a full-size rim just to test the size of it, and I'm awaiting a shipment of Polymaker's Polyflex just to print the entire wheel. I cannot wait. This is getting huge. And don't forget to subscribe and follow me on my socials so you don't miss when I release the small-scale version of the Miranda Blocks when they are ready. And thanks a lot to all my Patreons and members. Thank you. And now please go and make something!